The sine rule. As covered in earlier topics, we can use the trig functions, SOHCAHTOA, to find the length of sides or the size of angles in right-angled triangles. For example, in the triangle shown, the right-angle triangle shown, we have hypotenuse, opposite and adjacent. Sine x would be equal to opposite over hypotenuse. Cos x is equal to adjacent over hypotenuse, and tan x is equal to opposite over adjacent. We can use these trig functions, sine, cos, and tan, to calculate the length of unknown sides or calculate the size of unknown angles for right-angled triangles. But what about triangles where we do not have a right angle? To solve problems involving triangles which are not right-angled, we can use the sine and the cosine rules. Okay, let's draw our triangle, which is not right-angled. Triangle ABC is a scalene triangle. There is no right angle present. The first thing we want to do to understand these rules is to label the sides. And we label the sides based on the points. So side A is across from point A, side B is across from point B, and side C is across from point C. Now that we've labelled the sides, we can explore the sine and the cosine rules. Now the sine rule states that the ratio A over sine A is equal to B over sine B, which is equal to C over sine C. The cosine rule states that A squared is equal to B squared plus C squared minus 2BC cos angle A. Now both of these formula are provided in the formula sheet of the exam, so there is no need to memorize them. In this topic we will focus on the sine rule. To use the sine rule we need two sides and one opposite angle, or one side and any two angles. Basically, if we have three values, we can find the fourth. So the rest of this topic, we will explore the sine rule. In our first couple of examples, we look at how we can use the sine rule to find the length of a side. We are shown triangle ABC, and we can see that the side AC is 5 centimeters, angle A is 100 degrees, and angle B is 38 degrees. In part A, we're asked to calculate the length of side CB. So the first thing we want to do is label the sides. So side A is opposite point A, side B is opposite point B, and side C is opposite point C. Now looking at our diagram, we can see that we have one side, B, and we have two angles, A and B. So looking at the criteria for the sine rule, we can use the sine rule when we have two sides and one opposite angle, or one side and any two angles. So we can use the sine rule as we have one side and any two angles. Now the sine rule is A over sine A equals B over sine B equals C over sine C. We do not need all parts of the sine rule. We use the parts we need. So as we have B, side B and angle B, and we need side A and we have angle A, the part of the sine rule we use is A over sine A equals B over sine B. Now let's plug in the values we have. This gives us A over sine 100 degrees equals 5 over sine 38 degrees. Now to get A on its own, let's use our method line and multiply by sine 100 degrees. This gives us A equals 5 times sine 100 degrees over sine 38 degrees. Putting these values into our calculator gives us A is equal to 8 centimeters. Okay, in part B, we're asked to calculate the length of side AB to 1 decimal place. So we're asked to calculate the length of side C. Now, the relevant sine rule for us here is B over sine B, as we have both side B and angle B, is equal to C over sine C. Now, we do not have angle C. So how can we find angle C? For a triangle, we know that it has three straight sides and the sum of the angles equals 180 degrees. This means 100 degrees plus 38 degrees plus angle C will equal 180 degrees. So 138 plus C equals 180. Angle C is equal to 180 minus 138. So angle C is equal to 42 degrees. So using the sum of the angles of a triangle equals 180 degrees, we can work out angle C. Now that we have angle C, let's plug in our values to the sine rule. So 5 over sine 38 equals C over sine 42. Rearranging, we have c equals 5 times sine 42 degrees over sine 38 degrees, and c is equal to 5.4 centimeters to 1 decimal place. Now let's look at how we can use the sine rule to find the size of an angle. We are asked to calculate the size of angle QPR to 1 decimal place. So we have triangle QPR. We are given the length of side PR is 7 centimeters, the length of side QR is 11 centimeters, and we're given angle PQR is 33 degrees. Now the first thing we want to do as always is label the sides. Side P is opposite point P, side Q is opposite point Q, and side R is opposite point R. Let's also draw on the angle we're looking to find, angle QPR. Now notice that the angle we require is obtuse, is greater than 90 degrees. Now sine is positive in the first quadrant, but sine is also positive in the second quadrant. And in the second quadrant, the equivalent angle is 180 degrees minus theta. So what we're looking to do is find the size of the angle in the first quadrant, then use the quadrant rules to find the equivalent angle in the second quadrant. Looking at our diagram, we see that we have two sides and one opposite angle, so we can use the sine rule. Now, the sine rule for our question will be P over sine P, the angle we're trying to find, equals Q over sine Q, as we have both side Q and angle Q. Now, let's plug in the values that we have. 11 over sine P is equal to 7 over sine 33 degrees. Now, cross multiply by sine P and sine 33. This gives us 11 times sine 33 degrees equals 7 times sine P. Divide both sides by 7, we get sine P equals 11 times sine 33 degrees over 7. Now we want to take the inverse sine of both sides to get P on its own. So P equals sine to the minus 1, 11 times sine 33 over 7. Putting this into our calculator, we get P equals 58.9 degrees, which is our first quadrant value. We need our second quadrant value, so P is equal to 180 degrees minus 58.9. So P is equal to 121.1 degrees as our angle is obtuse. Now that concludes the learn lesson for the sine rule. As always, to bed in these skills, it's now time for you to go off and practice.